Okay, in this image right here, you can see there's at the Fukushima power plant there's 6 reactors. This was what one of the reactors looked like before the earthquake, and this is a few days after the earthquake. And you can see the top. Whoops, the top was blown off, similar to what happened in the Chernobyl situation. And again, it was because when the tsunami hit, the excuse me, when the tsunami hit, it knocked the power out at the plant. And even though the nuclear reactors are equipped with, you know, seismic detectors so that they know when an earthquake is coming, they did detect the earthquake as it was happening. The control rods automatically snapped down in place to shut off the nuclear, or to try to absorb more of the neutrons, but the cooling water was disrupted because the tsunami flooded out all of the electricity, and then the emergency generators were also flooded out. So then the reactors couldn't stay cold, even though the control rods dropped into place. The cooling water knocked out. Here's reactor 2. You can see it's getting ready to blow there on March 15th. There's reactor 3. That looks like a lot like the Chernobyl reactor, where the whole top, this is before and this is after, was blown off due to a chemical explosion. And this is reactor 4, similar deal. And then reactors 5 and 6 are still intact. They were able to restore the cooling water to that. It's a different part of the plant. Wasn't damaged as much by the tsunami. So you can see there that this is why people are afraid of nuclear power plants, is because if something that's not foreseen happens, such as the tsunami knocking out the backup generators that would have kept the cooling water going otherwise, then there was the, excuse me, chemical explosion. Okay. All right. So that's the problem with the nuclear power plants. Things happen that you don't expect. The other thing is that the cooling baths where the spent fuel cells were stored or are stored also got too hot and started giving off steam. The pools themselves were getting too hot and cracking, water's leaking out, and that water is contaminated with nuclear radioisotopes. Okay, and in the case of the fission products in a nuclear reaction, the most troubling radioisotopes that are produced in the fission reactions is the cesium-137, the iodine-131, and the strontium-9. And the iodine-131 is the biggest problem at the beginning. And if you all followed the news at all after the Fukushima power plant accidents with the tsunami, people were worried about the iodine-131. I've already talked about it. It collects in your thyroid, and at the relatively low levels that it was being leached out right after the tsunami, if people, could have caused cancer. So they really were avoiding the water and taking iodine pills and whatnot. The cesium has a longer half-life, and so does the strontium. And those two isotopes are also problematic because they can be taken up into the food supply. They can dissolve in water and then also get into the food chain, get into plants that absorb the water, and then people can eat them. And the reason why is because if we look at cesium and strontium on the periodic table, cesium is right here and strontium is right here. Cesium, when taken up by plants and animals, acts a lot like sodium and potassium, which are important micronutrients. And strontium, being right under calcium, acts like calcium. The body will be fooled and take up the strontium into the bones. And since it has such a long half-life, it could, over time, be continually emitting radioactive decay. They're all beta emitters, and they can all do damage to tissue. So that's why people are worried about nuclear accidents when the spent fuel cells or the fuel rods themselves are not fully contained and protected. Okay,